In this lesson, we're going to learn about lists. And a list is a way that we can store multiple pieces of information about a topic. So let's say we had a list for noodle soup. So a list is going to be enclosed inside of brackets. And we'll list ingredients for our soup. So our soup has water, it has noodles, it has chicken, salt, corn, right, etc. So all of the ingredients in your noodle soup, you can list them separated by commas inside of this list. Okay, now to access elements of a list, for example, if we wanted to print one of the ingredients in this noodle soup, we would put in the brackets the index or the position of the ingredient we wanted to print. And in a list, the first element is always 0. So water would be element 0. Okay, so if I go ahead and run this, I can see water outputs in my shell. Okay, if I wanted to print the last element of my list, right, water is position 0, index 0, noodles is 1, chicken is 2, salt is 3, corn is 4. So I would print out the element of my list in position 4. And there's our corn, right, the last element in our list. Okay, when you're accessing elements in a list, if you try to go too far, right, so 4 is the last index of the elements in our list, so if I try to access element number 5, that's going to throw an error, and that list index out of range is the error that we get, because there is not an element at position 5 in this list. Okay, so let's go ahead and try using lists in our Minecraft world. So we're going to make ourselves a little game that finds the highest and lowest position value of our player over a span of time that we pick. So let's make a list that's going to store the heights of the position, or of the player, and we'll make the first height the minimum. That'll be the minimum height of the player, and the second one will be the maximum height of the player. So I'm going to put 127 in, because our world is negative 127 to 127 in both directions. So I'm going to start with my max in the minimum position, and I'm going to start with the lowest, which would be negative 127, but we'll start at ground level, and that'll be our max position. Okay, now let's make ourselves a count variable so we can loop through a certain number of seconds. So while that count is less than 30, so we'll do this for 30 seconds. Okay, then let's get the position of our player. So world.player get tile position. Okay, now if the position of our player, the Y position above the ground, is less than the first element in our heights list. Okay, so as long as our player is less than the top of our world, 127, then we're going to change that position, heights element 0, and reassign it to the current low value, the height of our player, which is position Y. Okay, then we'll have an else if the position Y is greater than the heights element 1. So if it's greater than 0, which is our current value there, then we're going to reassign that to the player's position. Okay, now we'll need to increment our count variable, and we'll set the sleep to be 1 second. So each time we increment by our count, we're increasing 1 second. So this loop is going to run for 30 seconds while we fly around our world. Okay, once the loop is finished, then we can post to chat the results that we get. So let's report our lowest height, and we'll concatenate the height as a string. So we'll need to cast it, since it's an integer, inside the list. So it's going to report our lowest height, which is going to get stored in the first element in our list. And then we'll output to the chat the tallest height that we get to. So this will be the highest height, and that's going to be the position for element 1 in our list, right? That's going to be our maximum when this is done running. This is going to be the minimum when it's done running. So let's go ahead and run. And we'll come over here to our world, and we'll go downhill. Okay, so new low values are coming all the time. Okay, if we walk out into the water, right now we're going to be into even lower values. Let's see if we can make it into this dark area here and drop a little lower. And there we go. Okay, so name height is not defined. Oh, this is heights. So we're going to need to fix that error we've got there, so that it matches the name of our list variable. So let's climb back up here to a higher height. So we'll start up here again. There we go. Nice and high, and we'll run. Try this again. So let's go forward off of this hill. And we'll see if we can make it over here to this deeper water. Get an even lower Y value. So now we're under the water. And now we fell into that little hole. And then we could fly up. And there's our lowest height is -3. Our highest height in the world was 7 when we were up on the hill, right? The -3 is under the water. Okay, so let's go back and look at that noodle soup example that we did at the beginning. So we had a list of ingredients in a noodle soup. So our first ingredient was water, then we had chicken, we had noodles, we had some salt, we had some corn, and those were the ingredients that we included in our list for noodle soup. Now, if I wanted to add another element to my noodle soup, I could do noodle soup.append. And append is going to put whatever value I put in here in the argument of the function. It's going to append or attach it to the end of my list. So let's put some parsley in our ingredients list for our soup. So to test that it's there, to check that it did in fact get appended, okay, let's print that element in our noodle soup list. So water is 0, chicken is 1, noodles is 2, salt is 3, corn is 4. That would be parsley then as element 5. So actually before I run all of comment out this part so that we don't have to wait for all of that to happen. So we'll go ahead and run, and there we can see parsley got appended or attached to the list as element 5. Okay, we can also replace items in our list. So say I'm going on a salt-free diet, and I want to change a value in my list. I could change element 3, so 0, 1, 2, salt is element 3, okay, and I'm going to reassign that to be pepper instead. So now let's print to make sure that that change happened, and we'll go ahead and print out element 3 and see if it changed to pepper. Okay, and we can see in the shell that it did. Okay, another thing I can do with my list is I can insert a value. So let's say our noodle soup, we want to insert as the first ingredient. So this will be element 0, because 0 comes first. And we're going to put in front of water onions. So now let's print element 0 and see if that was inserted, the onions at the start of our list. Right? And there we can see the onions got put at the start of our list. Okay, I could also change my, or retrieve an index of a value from my list. So I could say value is equal to my noodle soup dot index, and let's look for the index of the corn in that list. So now we're going to print value, and we'll go ahead and run. Okay, and we can see the index for corn is now at position 5. Okay, if I wanted to delete that ingredient, then I could say del noodle soup, and we're going to delete that position value, which was 5. Okay, and we'll go up and run. Okay, and now that value, or position 5, is gone. So if I try to print that element, noodle soup, at position 5, right, now that's occupied by parsley rather than corn, because corn had been removed. Okay, strings can be treated like lists. So if we create a string called first name, and we'll create another string called last name, okay, then I could say that my initials are my first name string element 0, right? That would be the first letter of the first name. Okay, then we'll concatenate the last name element 0, and that's going to grab the first character in my string for my last name. So that'll be capital R, capital W. So if we go ahead and print to test that out, okay, now we can run, and initials is not defined. I-N-I-T, I-A-L-S, can't spell. So let's try that again. And there's the initials, capital R, capital W, output into the shell. So we can access the elements in a string, and that's called a substring. So we concatenated two substrings together to get a new string called initials. We can access the elements, but they're different from lists because strings are something called immutable. Immutable means they cannot be changed. So we're not going to be able to append, like attach or insert or delete a character, because once this string is initialized, it is what it is forever. Okay, so we can retrieve substrings from the string, but we cannot change its value. Okay, tuples are also immutable, and a tuple is whenever you have three values or more, right? So for example, when we did x, y, z equals 1, 2, 3, right? We've assigned these in parallel order. So if we try to print x, go ahead and run, right, there's my first value. So x got assigned to the value 1. Okay, I can create a tuple as a list by using parentheses instead of brackets. So let's say I have a list called ages. Okay, if I use brackets around these ages, 1, 2, 3, now this is a list, and those values can be changed. I can change them. I can append to the list. I can delete items. I can insert items, right? This is changeable. But if I make another variable called weights, and instead of brackets, I put those values in parentheses. Okay, now this is called a tuple instead, and that tuple is immutable. So it's a list that cannot be changed. So if you're putting data into a list and you don't want that list to be messed with, you're going to use a tuple instead, right? Parentheses around it, as opposed to brackets, which will make a changeable list. So let's go ahead and play with this in our Minecraft world a little bit. So we're going to add an import to the top. So let's import random. Okay, and then let's get the player's position. So the player's position is going to be world.player.getTilePosition, or we could even just do getPosition so that it's not just integers. Okay, and now we're going to set the x, y, and z values to the position x, position y, and position z values. Right? So this is going to be a tuple. Right? We're going to assign these values to x, y, and z in their corresponding orders. Okay, now we're going to do a forever loop. So while true. And let's take our x position, and we're going to increase that by a random float. So instead of rand int, like we would normally do, that would give us a random integer, we use the function uniform. And we're going to go from negative 0.2 to positive 0.2. Okay, then let's do the same thing for the z. So we're going to take z and increment it by a random float from negative 0.2 to positive 0.2. And then the y, we're going to get the height of our world. So world.getHeight, and that's for x position and z position. So that's going to get the height, maximum height of our world where our player is standing. And then we're going to take our player and set his position to X, Y, and Z, our new X, Y, and Z values that got changed randomly for X and Z, and the Y is going to be our height of the world, so the Y value won't change, but keep us where we're standing. And then let's sleep for a little bit, so we'll do 0.2 of a second, maybe even shorter. We'll do 1/10 of a second. Okay, so let's come back to our world and get out of the ocean. Whoops. Come up here and get onto land. Okay, so now we're on some grass. And we'll tap out of there. And then let's go ahead and run our module. Okay, so as we move around our world, right, we can see that it's sliding us around. Right, it's going to keep sliding us a random amount back and forward. Okay, so we can see that it looks like we're skating almost, like on ice. We're sliding around in our world. So let's go ahead and stop this program from running. Since we're in a while true loop, we're going to have to manually stop. So we'll come down to our shell and restart the shell. And right now we can see in our world that the program stopped sliding us around on the screen. Okay, so in this example, we saw that this function, the getPosition function, it returns a tuple, right? The X position, the Y position, the Z position get returned when that function is called. Okay, we can also return tuples from functions that we define for ourselves. So if, excuse me, we wanted to make a function called getDateTuple, and we were going to pass into that function the date in the format 2024 dash, see, today is the 10th, and it's the 1st. Okay, so today is October 10th, or October 1st, 2024. Okay, that's what I want to call in my function. So let's define our function, getDateTuple, and that's going to receive the string. So we'll call that date string. That's the string that we're going to pass in to that function. Okay, so its argument is that string. Then let's make some substrings. So let's say that the year is going to be the date string, and we want the year is 4 numbers, or 4 integers, 2024. That string, that's index position 0, 1, 2, and 3. So we're going to start at element 0, and we want the substring up to element 4, 0, 1, 2, 3, and then we put a 4 because this is going to grab the substring from 0 up to but not including element 4. So that's going to return to the year variable the 2024, index 0, 1, 2, and 3. Okay, then for the month, we're going to take date string, and our month is going to be 0, 1, 2, 3, 4, 5. So we start at position 5. Then 6, we want 7 is the one that's going to end, right? So this will give us the substring for positions 5 and 6, right, up to but not including the 7. Then the day from that date is going to be date string, and we're going to go to element, this was 7, 8, 9. So we want 8 from 8 to 10. Okay, and that will get us all of our values. So now we want to return those three things, the year, the month, and the day. So we're going to return the tuple to our calling function. Okay, so let's go ahead and print that result. Oh wait, hold on, actually, before we can print it, we need to assign its values. Okay, so when we call this, it's going to return a year, a month, and a day. So let's call those year, month, and day. Okay, and those will get assigned now to these three variables when we call that function. So then we can print to see what we've got. So we'll print the year plus, and then we'll do a comma, and then we'll concatenate the month, and then a comma, and then we'll concatenate the day. Okay, now we want these to be strings if we're going to concatenate. So let's go ahead and come up here and cast these integer values to be, or wait, these are strings already. Never mind. These are strings already, substrings. So we return year, month, and day. We should be able to concatenate those okay. So let's go ahead and run. And there's our output, the year, comma, space, the month, comma, space, and then our day. And another useful function that you can use with lists or with tuples is the length function. So let's take our name. So we'll say name, I'll make a list of names. So names equals, and we'll make Bob, Sue, George, and Sally. Okay, those will be inside of our list. So now I could print my names list dot length, or sorry, we'll do len, I'm in Java again, len for length, names. So this is going to output the length of our names list. So let's go ahead and run. Right, and there's the length of my names list. 1, 2, 3, 4 elements. Okay, if I append, so names dot append, and we're going to append to that list another name. Okay, that adds it on to the end. Now, when I print out the length of my list, right, we can see it increased to 5 names instead of 4. Okay, so let's go ahead and play with some of this in our Minecraft world. So we're going to use a new function to count the block hits in our game. So let's play this game. So we'll sleep for 30 seconds. So we'll see how many blocks we can hit. And we'll go ahead and make a comment. So this waits 30 seconds. Okay, then let's say our block hits is equal to world.events.poll block hits. Okay, and that's a function that'll come in with our Minecraft import up here at the beginning. Okay, and poll block hits is going to collect the information for us in our block hits variable. Okay, so this is going to get the list of block hits during that time that we're asleep. Okay, now we want to display that information. So let's say block hits length is equal to the length of that list that we just created, block hits. And then we'll post to the chat our score. So your score is, and then we'll concatenate on that, our block hits length. Right? That's how many block hits we're going to have. But that is currently an integer. So to concatenate it, we'll need to cast it as a string. Okay? So this will count the number of block hits as we go, and then it'll post our score at the end. Okay, so as we walk up to this building that I created, okay, now we'll come over and run. And the poll block hits records the swings of your sword using the right click on the mouse. So we're going to run our module, and then we can come over and right click, right, as we hit the blocks. And this is going to run for 30 seconds. Right? If we left click, those will not be recorded. Right? It's only the right clicks that the poll block hits is going to record. So we'll keep clicking until the timer runs out. Okay, and there's my score. So score is 32. So I had 32 block hits in the 30 seconds that the game was running. Okay, one last thing that I want to talk about with regard to lists and tuples is, let's go back to our noodle soup list. So we have water, salt, chicken, onions, parsley, right, as some of the ingredients in our noodle soup list. Okay. Another thing we can do is look inside the list to see if something is there. So if chicken is in the noodle soup list, okay, then we're going to go ahead and print yum. Okay, then let's say else print I prefer chicken. Okay, so let's go ahead and run. Okay, and we can see the output is yum because chicken is found in that noodle soup list. Okay, now if we change this to be beef noodle soup, okay, now when we run, our output is I prefer chicken noodle soup because chicken was not found in that list.